Yay, it worked. Okay. All right, so we've done lots of work on exponentials. Here we go with the logarithms now. Okay, so we have to review what they look like. So remember that exponentials and logarithms are reflected across the y equals x line. So this curve here, this is my exponential graph. This is the y equals x, that dotted line. And when I reflect it over, this curve down here is the logarithm. Okay, that's how they are related. They are the inverses of each other. Okay, so you have a few formulas on your formula sheet. So we've seen some of these things here before, like change of base, those kinds of things, very important. But we need to start with sketching. So question 1 says, sketch each function using a transformation of the graph y equals log e of x. So this is the log e of x over here. So because the exponential, remember, goes through 0, 1, this goes through 1, 0. That's your x-intercept. And then going that way. Okay, describe the transformation, write down the domain, and show and state the x-intercept and the vertical asymptote. So, y equals log base e of negative x. What? Describe, please. Describe the transformation. What are we doing? Karen, say louder. Yeah, that's right. Is that what you said as well? Yeah. That's totally what you said as well. All right, we are reflecting on the y-axis, okay, because we replaced an x with a negative x. Okay, that's reflecting. So all the positive x's, they're getting reflected over here to be negative, or vice versa. So that should make it nice and easy to draw, because we've got our normal logarithm up there. Has my asymptote moved? Not at all. So I have a vertical asymptote at x equals 0. My x-intercept will be moved over here to negative 1. And if I do the other point as well, I could go out to negative e, and it would be up here at a positive 1. And my logarithm will come down like that. Okay, we had some other things that we had to do. Write down the domain. All right, what's the domain? Possible x values. X is less than 0, can't be equal to, because we have an asymptote. X-intercept is at a negative 1, or I could write it as a point. I don't mind which way. And my asymptote, I've written it on the diagram, but I have a vertical asymptote at x equals 0. All right, that's our first one. We have a few more on the next page. Question B. We are now sketching log base e of x minus 2. What does the minus 2 do? Yes, moved down 2. Okay, so you hopefully, I'm kind of flicking back to look at the logarithm one now, but hopefully you've got in your head what it looks like. Yeah, okay. So my asymptote has not moved, it's still sitting over here. Vertical asymptote at x equals 0. Normally, my intercept would be here at 1, but I've got to move that down 2. So 1, 2, it's going to be down here. That's going to be the point 1, negative 2. Okay, so since my intercept moved down, I'm now going to have to find what the new intercept is over here somewhere. How am I going to find it? We're going to put in when y equals 0, correct? So let's go down here, hopefully I have some room. When y equals 0, I have 0 equals log base e of x minus 2. Move the minus 2 across. So it's log base e of x equals 2. Then what? We're sliding that base, that's right. X equals e to the power of 2. Okay, so you could work it out as a decimal if you wanted to, but e to the power of 2 is nice and exact. So let's put e to the power of 2 there, and my logarithm is going to come up like that. Okay, to make sure we've listed all the things we needed to list. What is my domain? X is greater than 0, good. My x-intercept is e squared comma 0, or yep, e squared, and my vertical asymptote is still at x equals 0. All right, another one, question C. Y equals log base e of x plus 3. Putting the 3 in the bracket, what does what? Moves it left 3 spaces. Well done. So, moved left 3. So this is going to move the asymptote. So, here is my graph. At minus 3, so that's 3 to the left, there's my vertical asymptote. Okay, my x-intercept is normally at 1, but I'm going to shift it 3 to the left. So where is it now? Negative 2. Okay, what else should I find? Yes, the y-intercept. So I sub in when x equals 0. When x equals 0, y equals log base e of 3, because 0 plus 3 is just 3. Okay, that's just going to be here. Ln of 3, and there is my curve. Have I labelled everything? I think so. All right, let's write our stuff down. Our domain. Very good. Our x-intercept was at negative 2, 0, and our vertical asymptote is at x equals negative 3. How are we doing? Is that all right? Good, because time to dilate. Stretching horizontally and vertically. Use dilations of y equals log e of x to generate a sketch of each function. Identify which dilation, also a shift in the other direction. Okay, so log e of 3x. The 3 is with the x. So that means I'm horizontally dilating. By what factor? A third, good. Because it should be in the form x over something. So I would have to put that x over a third, because the third would flip upside down to make a 3x. Yeah? Okay, so we are dilate horizontally by 1/3. Okay. Another thing that may be helpful here, because we're going to sketch it, we've got to sketch this. Y equals log base e of 3x. Using log laws, that's the same. Remember, if you've got two things multiplied here, what can you do? log of 3 plus log of x, because that's telling you that this dilate horizontally by a third is actually the same thing as this is the original graph and adding on log e of 3. Or in other words, moving it up, log e of 3. They're going to be the same thing effectively. So therefore, it is a shift up by log e of 3. That's a little bit easier sometimes to think of than dilating. Okay, so that does not move my asymptote, which will still be at x equals 0. So vertical asymptote x equals 0. Oi. Okay, so normally my intercept is at 1, but I'm moving it up log e of 3. Yes? So maybe here, this can be the point 1 log e of 3. I will need to find my new x-intercept by subbing in that x is equal to, sorry, not x, that y is equal to 0. So when y equals 0, I get 0 equals log e, I'm putting it into the original version, log e of 3x. Okay, because then I can do a sliding base. Okay, it will be 3x equals what? E to the power of 0. What does e to the power of 0 equal? 1. So 3x equals 1. Divide the 3 and x is equal to a third, which maybe is not very surprising. 1/3 is there. Okay, and here is my logarithm. Yeah? Okay, I think we have one final graph to draw. B. Y equals 3 log e of x. The 3 is in front of the logarithm, so it's not really with the x. So instead, we move it over to the other side so that it's with the y. Okay? So y over 3, that's in the right form. That means I'm dilating vertically, so I'm dilating the y this time, by a factor of 3. Dilate vertically by factor 3. Okay. What my asymptote is still going nowhere. Still sitting here. Vertical asymptote at x equals 0. What about my y, my intercept over here at 1? Is it moving anywhere? If I'm timesing all my y values by 3, it's 0. It's still not going anywhere. So it's there still. Okay. I'm not going to have a y-intercept, but we probably want to show another point. What would be a good point to show? An easy one to show is actually e, because when you sub it in, when x equals e, we get y equals 3 log e of e. That's why I chose it. What's log e of e? It is 1. So that's just equal to 3. Okay? So up here at 3, there it is. logarithm come down like that. All right, how are we doing? Okay with graphs? Yes? Maybe? Okay. All right, then we move on. Question 3, to simplifying with some of our log rules that we learnt. Hopefully we remember. We've used some of them already. Log base e of e to the 8. There is a shortcut if you remember it. Does anyone remember it? Sorry? Oh yeah, that's what I would do. But the log e of e will cancel out and the answer will always be 8 was the shortcut. But the 8 that is the power can come down to the front. And there's that log e of e again. Log e of e is just equal to 1, so that's why it is just equal to 8. All right, log e of e over here, that's a bit silly now, isn't it? That's equal to 1. We've done that a couple of times already. Log e of 1 over e. Oh, what was it? It is negative 1. Tell me some working out. What would I do? Log e of e to the negative 1. Take it out of that fractional form. Bring the e up. Yeah? So e on the bottom is a power of 1. When you bring it up, it's e to the negative 1. And then you can bring that negative 1 down the front again. Your log e of e is just equal to 1. So, of course, it's just equal to negative 1. Oh, these are getting a bit squished. Okay, D. Log e of 1 over e square root of e. Okay, so since we did that other one, we can do the same kind of thing. I can change the square root of e to be e to the power of a half. Because it's on the bottom, let's bring it up to be e to the power of negative a half. Yes? Then the negative half comes down the front. The log e of e is just equal to 1, so it must just be equal to negative a half. Question E. Log e of 5. What does that equal? E log e of 5. 5. Because the e and the log e, because I have the same base here, they will cancel each other out. And it is just equal to 5. Okay, so same thing for F. You got e here, and it's a log base e, so they will cancel each other out, and it's just going to be equal to 0.1. So then we have a reminder of our sliding base. Okay, and these are the log laws that we've already started using. Let's do some solving. Convert the equation into logarithmic form. Okay, so they're in exponential form, which means the e that is the base will be the base of the logarithm, and it will slide across to the other side. So the 5 will be by, actually I'll do the log first. It'll be log base e of m, because the e slides across to the other side, becomes the base of the log with the m, and that is going to be equal to 5. Remember that? Slide the base. Let's do it again. The e is going to slide across. This time the x is going to be by itself. The e slides across to be the base of the logarithm of a quarter. Now there's some other things you could possibly do with that, but we'll just ask to put it in logarithmic form, so we're just going to leave it like that. Okay, question 5, going in the reverse order. These are in log form, and we want to go back into exponential form. So the e is the base. The e is going to slide across, so the x will be by itself, because the e is sliding away. The e slides over to the other side, and it becomes to the power of -3. Yeah? All right, and the next one, the e is going to slide over to the left, so it becomes e to the power of a equals 5. So we can use these skills to solve things to 3 decimal places, like in question 6 here. Solve 2 to the x equals 100. It's not a nice number. We can't do it by doing same bases work. So instead we turn it into a logarithm. The base 2 will slide across to be log base 2 of 100. Now, if you're using a new calculator, you can type that in as it is, or you could do a change of base. What is it to 3 decimal places? 6.644. Let's do it again. Exchange of base kind of pointless, doesn't it, with the new calculators? All right. Keep the x where it is. Slide the 4 across, so log base 4 of the 55. Type it in, 3 decimal places. 2.891. Oh, too easy, right? We love logs. Question 7. Solve 4 to the x minus 7 times 2 to the x plus 12 equals 0. Would you believe me if I told you that that's a quadratic? It is a quadratic. Okay, it's a quadratic where the 2 to the x is what would normally be my x. Okay, let me rewrite the 4 to the x. 4 is the same as 2 squared, so 2 to the 2x, minus 7 times 2 to the x plus 12 equals 0. Now, we call these a reducible quadratic. What I can do is I can do a little substitution. I'm going to use the letter u, but it doesn't really matter what you use. Let u equal 2 to the power of x. Now, worth noting that this is also 2 to the x squared. Yeah? Can you see how that's the same as that? Good. Because that would mean 2 to the x, that's u squared. There's the quadratic. We have u squared minus 7, and this 2 to the x becomes a u plus 12 equals 0. Happy days, it's a lovely quadratic. And I can solve it to find u. So, what times to give 12 and adds to give minus 7? -3 and -4, good. U minus 3, u minus 4 equals 0. Okay, so that means using null factor that u equals 3 or u equals 4. But u is not what we were trying to find. The equation had x. So don't stop here. We now have to go back and find out what the x's are. And to do that, we put the u equals 2 to the x back in. Okay? So instead of saying u equals 3, I will say 2 to the x equals 3. And 2 to the x equals 4. And I want to solve those much, much nicer equations to find the x's. So this one, how am I going to solve that? Slide the base. So the x will stay. The base 2 slides over. Log base 2 of 3. Okay, so I'm just going to leave it exact. You could type in and do decimals, but if it didn't ask for decimals, exact is better, I think. Okay? Doing the other one. You could do a sliding base again, but this one's actually a nice one. You could change 4 to be 2 squared, which means if the bases are the same, powers must be equal, and x is equal to 2. Nice number. Wasn't that fun? Let's do it again. It was so much fun. Here we go. Question B. 3e to the 2x minus 11e to the x minus 4 equals 0. So that's going to be the same as 3e to the x squared So there's your squared part. Minus 11 e to the x minus 4 equals 0. So I'm going to sub in u again. Let u equal e to the x. The u is easiest to find with your second term. Alright, so whatever the nasty bit is in here, the second term. Sometimes you've got to fiddle with your first bit a bit to make the quadratic. Okay, so it's not going to be 4 to the x, it was the 2 to the x. It's not going to be e to the 2x, it's the second term. This one gives away the u, alright? So, that will make 3u squared minus 11u minus 4 equals 0. Oh, lines. Okay. This is non-monic. So to factorize this, I'm going to have to times the 3 with the 4, which is negative 12. So I'm looking for two numbers that can't give negative 12 and add to give negative 11. They are... Anybody awake out there? Negative 12 and a plus 1. Good. 3u squared minus 12u plus u minus 4. This is the splitting the middle term strategy. Okay, then we factorize in pairs. So I can factorize a 3 and a u out of the first two terms. That will leave u minus 4. Ooh, look at the third and the fourth term. U minus 4. Don't even have to do anything. So let's go bracket u minus 4 equals 0. Then we take the u minus 4 as a common factor, and the 3u, what's next? Plus 1, good, goes in the second bracket. Then we can finally null factor. I'm going to get u equals 4 from the first one, or 3u equals negative 1, u equals negative a third from the second. But I still have to get x. Okay? So u equals e to the x is 4, and e to the x equals minus a third. Okay? What about this e to the x equals 4 business? What should I do? Slide the base. So keep the x here, slide the base e over, log base e of 4. There's your first one. What about the next one? You could keep the x, slide the base, but there's a problem. Can you do log base e of a negative number? No. Logarithms go like that. Which means, unless you've got some other brackets or something in there, there's an asymptote of 0 and nothing exists over here in negative numbers. Okay? So, that means that this one has no solution. Okay. One more question. C. Log e of x minus 9 over log e of x equals 0. I've just been subbing stuff in. So the part that is making this equation complicated is the log e of x. So we can we could let u equal log e of x and try and solve the rest of it, come back to find the x afterwards. Alright? So my equation would change to be u minus 9 over u equals 0. Is that nicer? A little bit? I still can't solve it while there is fractions with my u on the bottom. So what should I do next? Multiply everything by u. So it would be u squared minus 9 equals 0. That's a difference of 2 squares. So that means u minus 3, u plus 3 equals 0. So that u equals 3 or u equals minus 3. And now we come back to the x part. or the log part, u equals log e of x. So log e of x equals 3, or log e of x equals minus 3. What should I do next? Sign language. Slide the base. Yes. All right, so for the first one, keep the x, slide the e over, so it'll be e to the power of 3. Going to keep it exact. That's it. Do the same thing for the other one. Keep the x, slide the e over, e to the minus 3. Yep, that still works. There's my second solution. We are done. All right. 6F.